So today what we'll be working on is exponential word problems. We'll actually be doing that for the week. So today we're going to work on growth and decay problems. So I would like you to put me on pause and do the try this, which is solving the exponential equations, which is what we worked on last week. Okay, so remember when we solve an exponential equation, you have to get this base here, which is 1.27 that has that x as the exponent. You have to get this to be isolated, so we have to get rid of the 5. Now remember, we cannot multiply 5 times 1.27. Okay, so how do we get rid of the 5? If this is 5 times, we divide by 5. So divide both sides by 5. So 20 divided by 5 is 4. Equals 1.27 to the x power. So it is an exponential equation. How do we know? Because the exponent is an x. So what we use is log. So we log both sides. So we have log 4 equals, remember the exponent goes into the front. So it's going to be x log 1.27. Solving for x. This is x times log 1.27. So divide both sides by log 1.27. Plug that into your calculator. You can round to the nearest tenth. So you get x equals 5.7999, which rounds to x equals 5.8. Okay, so let's take a look at the growth and decay formulas here. So the growth and decay formulas are very similar to each other. One just has a plus, one has a minus. So the growth is A equals P times 1 plus R raised to the T power. And the decay is A equals P times 1 minus R to the T power. So let's write down what everything represents. So A is your final amount. P is your initial value. Or your starting value. R is your rate expressed as a decimal. So remember to change the percent to a decimal, move the decimal 2 places to the left, and T is your time. All right, so let's take a look at the first example. So we have here, the population in Clarksville is 15,127 people. The population is increasing by 12% a year. How many people will there be after 5 years? Round your answer to the nearest person. Okay, so it is a population growth. So let's just write down the formula. A equals P times 1 plus R to the T power. So we're starting off with 15,125 people. We have a 12% increase every year. We want to know how much is there after 5 years. So it does say how many people will there be. So that means I would be solving for A. So we have A equals, the initial population is 15,127 times 1 plus your rate. So I have 12%, which is going to be 0.12. 0.12. And my time, I want to know how many people after 5 years. So my time is 5. So that you could just plug in your calculator all at one time. So I'll give you a second to plug it in. So you get 26,658.9426. To the nearest person would be 26,659 people. Okay, let's look at the next part. How long, so if it says how long, that means we're solving for time. How long will it take for the population to become 40,000? Round your answer to nearest tenth of a year. So let's write down the formula. A equals P times 1 plus R raised to the T power. So I want to know how long. So that means I'm going to solve for T. I'm not plugging anything in for T. I know my initial population, remember, was 15,127. 1 plus your rate, which is 0.12. Remember, we're solving for T. And I want to know how long it's going to take me to get to 40,000. I want my final answer to be 40,000. Okay, so again, remember, we have to get rid of the 15,127. You could add these together if you want to make it 1.12. But remember, do not multiply these here together. So we will divide both sides by 15,127. And you get 2.644278443 equals, and I'll make that 1.12 to the T power. So now we have the base, right? We have this base here with the exponent, exponential, so we use logs. So it's log 2.644278443. Exponent goes into the front, T log 1.12. Now we're solving for T, so divide both sides by log 1.12. So you can plug that into your calculator. So it's log 2.644278443 divided by log 1.12. And I have 8.58. And to the nearest tenth of a year, it will take approximately 8.6 years. Okay, so let's flip it over and take a look on the back. Okay, so the second example says a certain species of fish in Lake Centereach is decreasing at a rate of 4% every year. At the beginning of the year, there were 8,246 fish. How many of these species of fish will there be after 4 years? So we are decreasing. So it's a decay. So let's write down the formula. A equals P times 1 minus the rate raised to the T power. All right, so I want to know how many fish will there be after 4 years. So that means I'm solving for A. The initial amount of fish is 8,246 times 1 minus, so it's increasing at 4%, so that's 0.04. And I want to know how many fish there'll be after 4 years. So that you could just plug in your calculator all at one time. I'll wait for you guys to do that. So you get 7,003.7. And I did forget to put what to round it to, so we'll just round to the nearest fish, which is 7,004 fish. Okay, so let's look at the next part. So the next part says, how long that means we're solving for time, to the nearest year, tenth of a year, will it take for the species of fish to become half its initial population? So let's write down the formula. A equals P times 1 minus R to the T power. So remember, the initial population was 8,246 fish times 1 minus 0.04, and we're solving for T because it says how long, that's time, to the nearest tenth. Now, how much fish do we want? Well, we want it to become half the initial population. The initial population is 8,246, so I have to divide that by 2 if I want half of that. So I'm going to go over here on the side, 8,246, divide that by 2. And we want the population to be 4,123 fish. So 4,123. Okay, so again, we cannot multiply these together, so we have to get rid of this by dividing by 8,246. So we'll get 0.5 equals, now the 1 minus 0.04. So that comes out to be 0.96 to the t power. And now we're going to log both sides. So it's log 0.5. Remember, the exponent goes into the front. T log 0.96. Solving for t. Divide by log 0.96. So plug that in your calculator. Log 0.5 divided by log 0.96. So we have 16.9797. And it says to the nearest tenth of a year. So the 7 rounds the 9 up to a 10. So it's 17.0 years. Okay, so that's it. And everyone have a great day. Stay safe.